Alright, let's continue General Chemistry Part 25. We already introduced precipitation reaction, which is defined as a reaction must have one of the products in solid physical state, right? Become precipitate down out of the reacting solution, right? The reacting chamber or reaction beaker. And then down to the bottom of the beaker and then separate from the reacting solution, and then the reaction stops basically. And the remaining cation and anion pairs, right, from the reaction will not be able to form any soluble or gaseous products to be separate from the solution. Then they stay in the aqueous solution as cation anion pair. They don't seem to have anything to do with it, so that's the end of the reaction. And they have a name, we call them spectator, because they did not seem to actually participate in the reaction. Now let's get that point later on. So let's find some examples we are able to explain the whole process. Let's pick two soluble ionic compounds already in aqueous solution, and then we mix them, right? And what happened afterwards? Right after that. So we have to pick up two ionic compounds. They are soluble in the aqueous solution. So we have to look at the table right here we call solubility rule, right? And look at the A section, right? Compounds are soluble. Now we already involved a couple of cases in the past, like sodium chloride reacts with silver nitrate, and then they exchange partner during double displacement or double replacement reaction, and then the silver chloride, right, is insoluble salt. Silver with chloride is exception from the soluble, right? It becomes insoluble salt, precipitate down as precipitate, right? But that's a simple one. We're going to pick a little bit complicated. Let's pick up a polyatomic cation, ammonium, right? And then combine with let's say combined with halogen, chlorine, chloride. So we have ammonium chloride, and then let's see, react with what? Let's react with silver nitrate, right? Let's pick the next silver nitrate. So silver nitrate is also nitrate is always soluble, right? So let's pick these two. So what do you say? Ammonium. So ammonium, right, chloride. Now that is aqueous, right? And then you react with another soluble. This soluble ammonium is always soluble right here, right? And then the silver nitrate. All the nitrates are soluble right here, right? And then so it's aqueous, right? Now, before you mix them their aqueous solution, they have cation silver anion nitrate in that aqueous solution. Here we got the ammonium cation and the chloride anion in that aqueous solution. When you mix them, they have the chance to encounter, run into, collide each other. But before that, they have to what? Dissolve and dissociate, right? When dissociate, this one took off from the connection with the chloride, and the silver taking off from the nitrate, so become cation and pair. And then they run into each other, collide each other, you know, the molecular theory, right? Kinetic theory, and they run into each other, and if there's a driving force to make something solid and no longer can separate in the aqueous solution, then they become heavier, they will descend to the bottom of the beaker. That is a precipitating reaction, it's complete. And the driving force driving towards that direction, then that will be a spontaneous, right? So that's where we talk about a driving force. So what happened? What happened actually, it goes to dissociation, right? So that actually made these two ionic compounds soluble into the solution. They become what? We can start from solid, and add water here, become this and that, right? Then these that become what? Separated, right? Let's do that. Let's do that. Why not, right? Why not? So you make a solution. You from solid, right? You from solid. Those are salts, right? You bought from the bottle, right? So they are solid, and that's a solid. And then you drop into the water solution, right? That's a liquid. And then you make what? You make, that's a chemical change, right? Chemical change, because this solid become aqueous solution, become cation. So you have what? You have ammonium 1 plus, that's aqueous, and chloride 1 minus, also aqueous. And then you add what? You add the silver, right? 1 plus is aqueous, right? Also aqueous. And nitrate 1 minus, also aqueous. So that's dissolution and that's dissociation, right? Dissociation. So dissociation. Right? Dissociation into water. Now we have these, then you have a chance to exchange partner. So that's called double displacement. Why? Because driving force says silver chloride will form solid. So these two will have more chance to combine into a new compound as precipitate. And these two were still in the solution as soluble ions. Why? Ammonium always soluble. Was anything else? So this is something else. It's still soluble. So this is going to be separated. And this nitrate always soluble. No exception, right? So we are able to, from there, this dissociation process, right? Is that clear? Is that big enough? I'm going to make this a little bit so you are able to see from the video camera, right? So this is going to be, the water is dissociation, right? And then now we start, that's the first step. And then second step is going to be what? The wait a minute, let me copy it, right? Let me just copy it. It's going to be ammonium, so ammonium, aqueous, 1 plus, right? We add the chloride, 1 minus, aqueous, add silver, right, 1 plus, cation, aqueous, plus nitrate, 1 minus, aqueous, right? Then what? They have an exchange partner, right? The chloride goes to silver, replaced with this, so you have this react with this, right? So what happened? On the other side is going to be what? On the other side is going to be, let's continue from here to here, right? So from here to here is going to be AgCl. What is that status? Physical property? Chloride, with the exception as silver is not going to be soluble. Chloride silver will be a solid because of the exception, right? So that is going to be solid. If it's solid, it goes down to the beaker, bottom beaker, and then precipitates, right? And add what? Add these two, ammonium and the nitrate. Are they combined to a compound? Yes, they will. If you evaporate all the waters, you still have a lot of water down there, right? It's an aqueous solution, right? Aqueous solution. The water's still there, always there. Until you dry them off, completely evaporate all the solvent, and then you are able to recover the ammonium combined with nitrate, we call ammonium nitrate, right? That would be the compound. It's an ionic soluble compound, right? But you won't get it because the water molecule we talk about again and again and again. It's so polar, it's able to what? Upheld the negative charge anion nitrate with its positive N. What is that N? 2 hydrogen, right? Or upheld, hold up, the ammonium cation with its negative N of a water molecule. What is that N? they ended on the oxygen side, right? Two lone pair electrons. Then they were hold up there, not be able to combine between these two because they are the desolvation power from a water polar water molecule is stronger than if we combine to a ionic compound in the solution as a molecule. That doesn't happen, right? We say it doesn't happen because they are not molecules. So it will stay as cation and anion pair remaining in the aqueous solution. So we better not write ammonium nitrate here, but we still write what? Ammonium add and nitrate. So you have ammonium 1 plus aqueous and nitrate 1 minus aqueous. Now this is what we call what? We call complete ionic equation. Now this is called a complete ionic equation. Alright, because why? Nothing is missing, right? Everything's there. But if we look into this complete ionic equation, right? And we know silver chloride is a solid precipitate out of this solution. But in the solution, you still have something as reactants exactly identical as the products. Even this reaction seems to be stopped, complete, right? That's complete. This precipitate, there's no more reaction going on. These are not going to combine until you drive off all this water. We said it all over and over again, right? So these two cation-anion pair, right? Cation-anion pairs are identical on both sides. What do we call them? Because they don't seem to participate in the real reaction. What's the real reaction? The chloride and the silver combine into a silver chloride precipitates as. That's the real reactants. That's the real product. These two are identical on both sides. They don't seem to participate in the real reaction. So what do we call them? We call them spectator. The spectators. What is spectator? The identical what? We don't call it cation-anion, we just make a general form called the identical species in the reaction doesn't seem to be participate the reaction process and can be cancelled because they are identical on both sides, right? The identical species are enough space species, right? Species, right? Who do not seem to participate the reaction process, right? Reaction process, and can be cancelled out of the complete ionic equation. So that is the definition. So who are they? Spectated ammonium, spectated nitrate, cancel spectated ammonium, cancel spectated nitrate on both sides. That is, these two pairs are the identical pair. Before and after reaction doesn't seem to participate part of or join part of as part of the reaction. neither reactants nor product, right? So they are identical on both sides. That's called a chemical reaction equation. The equation, in mathematical term, equation means the two expression, right, connected with a equal sign in between. Now that's in mathematics. But in chemistry, the two expression of chemical species, right? They react each other plus, and they react plus means react, and they're joined by an arrow of the direction of the reaction. But they have what? They have something to back off their theory because they are equal. Why they are equal? Because the law of conservation of the mass keep them equal, right? They don't. Mass cannot be created or destroyed easily, and then but preserved, right? So that's conservation of law and mass. So that's why they're equal. They're identical as their species, their status, their physical state, aqueous, and then the number of nitrogen, number of hydrogen, number of oxygen, all identical. The composition of the structure NO3 also the same, charge the same. So they are 100% identical, they are able to cancel each other. So when it cancels out, what are left over is the true reactants and the products of the reaction. What do we call them? That's the reaction equation. We are calling them net ion equation. Now let's put down the. So the real reactants and products, right, are the component of the net ionic equation. Now what is this case? What is left over? Silver, 1 plus aqueous cation react with chloride, 1 minus anion, both in aqueous solution to start with as reactants, but then when they collide into each other in the chamber, in the aqueous solution, so many of those run into each other so easily, close range, then they become combined to solid. That's the driving force, making solid, precipitate. That's the driving force, driving reaction from what? From left to the right. That direction only one way, irreversible, and that is spontaneous. And that is the completion of the reaction. So form what? One arrow, right? One arrow to silver chloride and the solid precipitate down to the bottom of the beaker, and then that is correct. Then there is also a zero charge neutral compounds, right? Because +1 and -1 make the whole thing is neutral, zero, and then now we have a balanced chemical reaction right here. One silver on either side. One chloride, one chlorine on those. So that is mass balanced. First check out, right? Second, we double check, right? Not check the mass twice. We check something else. By law of conservation of mass, it fits, right? It fit into mass, one silver atom before and after. One chlorine atom before and after. So the mass is balanced and conserved, right? The second one is charge. What does charge stands for? Charge stands for energy. Now we're going to go a little bit deeper, right? So we not just throw the type of chemical reaction, throwing couple examples. We go detail. Oh my God, this is very detailed, right? All right. Not only detail, we review lots of things along the way, so you have a chance to be exposed to a lot of learned knowledge you not picked up at the time supposed to be, because you're not familiar with your entry level, right? Learning, start beginning, right? The beginners, right? So I try to help you to build up all those knowledge, all interwoven, interconnected, now all come to play their roles. So you are able to have a big picture, a complete picture. What about precipitation reaction? What is the law of conservation of energy? What is, now that's what we talk about. What is law of conservation of mass? And what is the law of conservation of energy here? +1, -1. RD cancels charge, becomes 0, yes. But in charge, 1 plus 1 minus give the total is 0, right? So the charge also balanced. This is 0 on this side, +1 minus 1 is 0. On the other side, that's products is 0 because compound is neutral. So both laws of conservation of mass as well as energy are satisfied. This is very, very complete in the knowledge, and we introduce all the way. Just one example, right? We can pick another one, right? Let's pick up another one. Is that clear? Did I have a chance to erase it? Let's erase on top, right? So, one more example, right? So pick up something for me, or I'm gonna do that for you. Now this is easy one. Now, silver nitrate, we'll be using silver nitrate twice. Now what about others, right? So we use soluble, right? We always have to start from soluble and find out what is insoluble. Otherwise, you're not even starting the reaction, because when it's solid, you know, you dissolve, right? To have a chance to collide with other compound, to have a chance to mix and the collision, right? Through collision to form new compound. So we have to start from soluble compound. Then we have to also involve something today to let you have idea how do we predict what compound react with what compound. They are both soluble. They were able to form a solid precipitate, right? Solid products, or they don't form solid products still in the solution as aqueous solution, cation anion. Then we are calling them no reaction. We are talking about it. This is dissociation, just dissociation, not reaction. So let's see if we'll pick another one. How about sulfate, right? Let's pick sulfate, right? Sulfate, almost all sulfate except the strontium, barium, and lead with sulfate is going to be insoluble. But sulfate with anything else will be soluble. So what is sulfate we want? So another one, let's see, what happens? What happens? Oh, the pen dried up. What happens? All right. What happens if? Oh yeah, that's the wrong pen. That was the wrong pen. If what? If let's pick up a complicated one. If calcium sulfate, right? Calcium sulfate, aqueous solution, right? Mixes with let's see, sulfate will form insoluble, this exception, right? Insoluble salt, precipitate down, then we're going to choose something, let's say lead. How about the lead, right? Lead has two places considered as exception. One is with halogen, right? Lead chloride, lead bromide, and they are not soluble. That's the exception, right? Because they are soluble, but except these three, right? Also, lead will not be soluble with the sulfate, right? But calcium seems to be out of that exception, is soluble, so it's aqueous solution. Now we are going to choose, let's say, anything else. Okay, let's see. Ammonium again with a polyatomic. With ammonium, right? Because it combined with anything will be still soluble. Let's pick up one of those insoluble anion right here. How about a phosphate, right? Phosphate. Ammonium phosphate. Now ammonium phosphate, PO4, right? 3 minus. So PO4 It's 3 minus, this is 1 plus, so what happened, right? 3 minus, right? Now you have to have 3 of this to combine 1 of that. So the parenthesis supposed to be applied for the ammonium, right? Ammonium 3, so plus 1 inside 3 with plus 3, and outside will be a phosphate, is minus 3, right? And it is aqueous, am I right? Right? Am I right? So what happened, right? Right, so let's see. Alright, still have time, I still have 4 minutes. Let me finish this easily. So what is the products? Can we predict, right? Number 1, predict the correct products of the reaction, right? So if we consider that is a B, C, D, right? The C is got 3 of them, D got 1, A is 1, the B is 1, right? Then we exchange partner, then you have calcium will be combined with the phosphate, with the calcium phosphate, and then ammonium will combine with the sulfate, right? Ammonium will combine with sulfate, right? And, what happens to this product? So exchange partner, so we predict the products will be what? The calcium with the phosphate. Now calcium 2 plus, right? And does calcium, right? Does calcium and the phosphate still insoluble fit into this category so that we are able to consider as a precipitate? See that? Exception is ammonium, right? Ammonium is aqueous. First A, alkaline metal, not second A. Calcium is second A, right? 2A. So this one will be a solid. It is going to be a solid precipitate, right? Is that clear? Because you check exception does not include 2A. It only include 1A right here, right? So, but is this a correct formula? Phosphate is 3 minus. This is 2 plus. They got to have a least common multiple as a 6. So if a 6, then this should be 3. And this should be what? 2. So 3 minus times 2 is 6 minus, 3 times 2 plus, 6 plus. So that now is a neutral compound, right? And then what? If you have this compound, and then sulfate will combine with ammonium. Ammonium sulfate. Now ammonium is plus 1, sulfate is minus 2. So you got to double this into the formula. So this gotta be 2 outside. So plus 2 plus, and 2 minus. That's neutral. So these are 2 parts. So if we are able to write a complete molecular or complete chemical reaction equation. So we start from here. Calcium sulfate, aqueous, react with ammonium phosphate, right? Also aqueous, right? And then they dissociate, right? Dissociate. We are going to do that, but we're going to just complete. So let's see. This is going to be forming what? Forming calcium phosphate, solid, precipitate down, and what? Ammonium 2 sulfate. Phosphate sulfate is sound kind of confusing, right? But that's a complete reaction, but it's not balanced, right? Because it's calcium only 1, that got 3, so you have the multiply 3, and then that's a balancing equation problem. We can deal with later, but now we may have to just balance the calcium, the 3,